Hey, it's Peter from DevMentors here, and welcome to the second episode of building our FeedR app, which is a simple, distributed microservices-based application for aggregating some data and then pushing some notifications, streaming some data, and so on, as you will see later on in the future in the next episode. So, within this episode, what we are going to focus on is actually not really adding some application logic or some infrastructural code or cross-cutting concerns yet to our code base, but instead, we'll just take a look at some nice and simple to use tools that can help us with actually running our services. Because as you might have already noticed, whether you have cloned the repository or seen the previous episode or not, if we open the solution, there is quite a few apps, right? So within our solution, you can find that we have about 6 applications to run, right? We have our gateway, which is not functional yet. It just starts, but does nothing really special. We have our free feeds applications. So one feed for returning some kind of quotes, pricing, currencies, the other one for our news worldwide feed, and the next one for our, let's say, weather temperature feed. And then we have additional services like the data aggregator and the so-called notifier. So you can see we have 6 apps in total, and as you can imagine, running them all through the IDE or trying to debug them, especially when you try to run them all at once, sometimes you might find, let's say, that running this through the IDE is too slow, or maybe you want to run them on a separate server where you don't really want to install the IDE. Maybe you just want to run them quickly, or have some options for easily scaling them horizontally by adding more instances, and so on and so on. So within this episode, we are just going to take a look at the free tools that can help us with building and starting our apps using some built-in commands into such tools. So we'll take a look at the tool called .NET TIE, we'll take a look at the PM2, and finally we'll take a look at the Docker and Docker Compose, and we'll see how we can actually provide some custom Docker files and how we can, let's say, run our .NET Core or .NET 6.0 actually applications by using this single Docker Compose app command and by providing our YAML file containing the service declaration. So let's jump into the code and let's check out these tools. Alright then, as discussed, let's start with the first tool that might help us to actually compose and run our apps by providing a single file, single configuration, and then running and stopping our services within a single command. So the first tool that we are going to use is called .NET TIE. So if you go to this public repository .NET/TIE, here you will find some documentation there. And if you navigate to this FAQ, here you might find some answers, and in the documentation section, you might find some additional interesting stuff, because even though it looks simple, it's actually a quite powerful tool. So let's take a look how we can start using the TIE. Well, if we go here to the getting started, you will find this command, how to install this tool using just a .NET tool installer. So I have already installed this one on my machine. And then once you have it in place, you can just type something like TIE run and start your apps. But of course, before we'll start our apps, we need to somehow provide this configuration file. So let's take a look how it can be done. We'll jump here, and then next to our SLN within the root directory of the repository, let's create a new file, and I'll just save this file following this convention here. All right, so within our gateway here, I'm just going to save this file, and I'll just call this TIE YAML. All right, and then we might start adding our services into this .NET TIE. So at first, let's just provide a name. We'll call this FeedR, and then the list of our services. So as you can see, this is a bit similar to, for example, Docker Compose file. And actually that's partially true, because also, for example, by using the TIE, you could run, for example, your Docker images, you could run your containers. So you could actually even skip using Docker Compose if you are using this, but we'll use this Compose anyway within this episode, and just build your overall infrastructure and services within this Thai YAML. So let's start with the gateway, for example, as our first service. So I'll just provide here some name. Let's call this FeedR-YAML. And then I'm going to provide the path to our project. So we want to start our gateway, which lives under src gateway and then FeedR gateway directory. So the path would be gateway and then FeedR.gateway, and then there's our csproj name. Okay, so I'm providing a full path to the project that should be built and should be run from the Thai perspective. Then we could also provide our bindings, for example, for the ports. So I just want this gateway to be exposed under our already defined 5000 port. And then we could, for example, also override our environment variables. So once again, something similar to what you could, for example, do within the Docker Compose file or Docker in general. So here, let's just provide our environment variables, and I'm just going to provide here the name. Let's just call this, let's just use our ASP.NET Core environment variable, and then the value, for example, development. So if you like to override your settings, for example, you like to have something like Thai app settings.thai.json file here, you could just easily override it here. And then we would add our remaining services. So let me just grab the already prepared file and then copy and paste the full Thai project. And let's see how this Thai could actually look like. All right then, so there is our whole Thai YAML definition. As you can see, the same stuff for the remaining apps. So the aggregator, notifier, and our free data feeds with just this different project path pointing to the different project directories, right? To different csproj files. And now how we can run the Thai. So actually that's very straightforward. Now let's jump back into our console. As you can see, there is our Thai YAML file. So by the convention, it should be picked up. And then we can type something like Thai run. On my current machine, which is the M1 chip, I'm still having some issues, at least when I'm recording this video, as the Thai has a reference to some older version of the framework and I didn't manage to run it yet. So I'll probably just wait since it's compatible, fully rebuilt to .NET 6.0. But for example, if you were to run it on Linux or Windows, which supports also these previous versions and there are no issues, if you were to run this Thai run, you would see something like this, right? So you type Thai run, and then as you can see, your services are being built. And then after a while, your services are starting, as you can see in the console. And then you have this endpoint, this public Thai URL, where you can navigate to, see this nice dashboard, browse your apps, browse the logs. And then if you want to stop it, you can just Control-C and kill your services. So very nice tool to use, very easy to use. But like I said, the Thai is much more than that. For now, we have seen just a simple way to run our services one by one within a single command. But then, as I already mentioned, you can check this more advanced, let's say samples of the documentation. And you could, for example, use some additional features like service discovery. So you could talk between your services using the alias provided within the Thai YAML file without a need to, using the hard-coded URLs and other cool stuff. So I would say that Thai is a very nice tool. And as long as you can use it, it might help with your local development, especially with your local development and running your services at once within a single file by using the single file. All right, so now let's take a look at another tool, very nice tool, which has been there long before the Thai has been released for the first time. And this tool is called PM2. So PM2 is actually, as you can see by its name and by description, it's kind of advanced process manager for Node. But even though that you can install it through the npm, so you need to have Node.js installed on your machine, you can still use it for different kinds of apps, including our .NET Core apps. So if you install this, for example, by using this npm install PM2 and then -global command, what you will see is that within your console, when you type something like PM2, you will see this list of, let's say, sample commands that you can use within the PM2. As you can see, that's, well, quite an advanced tool with quite a lot of stuff in here. So let's take a look how we could use the PM2 internally for our .NET Core services purpose. So I have already installed this, as you can see, and as you have guessed already, probably, for PM2 to run it, we'll need to provide a separate file. So I have one .yaml file, and then let's just provide a new file. So I will just call this one PM2 YAML, because we are also going to provide here some kind of the YAML definition. And then I'm just going to put there our apps, list of our applications, and then let's start with the application name. So let's stick to the same convention as we did within a tile. So let's start with our name and then the script. So what script I want to run on this particular application, on this, let's say, particular executable file in our case. So I want to run some kind of .NET run command. So this is some kind of a system command that I want to run in order to, let's say, start the app. And then I'm going to provide the path. So once again, just like in a .yaml file, we are going to provide the path for our projects. So here, let me just provide here the path for our gateway. As you can see, I'm not providing the path to the whole CS project because PM2 is not a tile. It doesn't care whether we are using .NET Core or some other technology to run our apps, which is why I'm providing here the script and then the directory under which this particular script should be executed. And then I can provide a bunch of additional stuff. For example, something like the maximal number of restarts. So if we can't run the app for some reason, and maybe we try to run it 3 times, there are 3 restarts in total, and if it's still not working, let's just kill it, okay? Let's just skip the app. And then one by one, we would actually, just extend our PM2 file, PM2 YAML file, with additional service definition. So once again, let me just grab the complete file, let me paste it here, and then we can see how this PM2 is actually going to look like. All right, so there is the whole definition of our PM2 file. As you can see, pretty much the same stuff we did, like we did within our .yaml file, where we just have the list of all services, aggregator, notifier, and our free data feeds, just pointing to different directories, but using the same .NET Run script to run our projects. So now let's try to run PM2, all right? So let's type our PM2 start and then point to our PM2 YAML file. But before we do it, you might actually want to rebuild your services, just make sure that they are running, and then let's run our PM2 services with PM2 start and then the path to our YAML file. So let's see if this is going to work. And what we can type now, for example, is something like, let's say PM2 logs. So we have this nice dashboard, and let's just type PM2 logs. And there are our services. So let's take a look. Let's try to navigate here, and there is our gateway. And for example, there is our aggregator. So our application seems to be running. But as we have seen, the PM2 has much more to offer. And for example, I can do something like, let's say, PM2 monit. And we have this very nice dashboard within this console, which is very cool. So you can, for example, run it on your deployment server, and you have a very nice insight about what's going on within your apps. So for example, if I were, let's say, to run some requests within our gateway here, let's take a look. And then as you can see, there are the logs. So I have these nice interactive dashboards. And like I said, this is just a tip of an iceberg. And within the PM2, you can do much, much more cool stuff with some services reloading, scaling, and so on and so on. So let's just stop it. I'm just going to type PM2 delete and want to delete our services from this file. And now there is no apps, so nothing is running here. So very nice tool to use, and a bit more, let's say, universal, generic than, let's say, .NET Type, because we can use it with different kinds of apps. So the last thing that we want to do is try to play with our Docker, okay? So like to containerize our apps, because if you have ever worked with Docker, you pretty much know by now that the containers are everywhere. They are kind of taking over the world, and most of the DevOps deployment stuff, even some kind of testing, CI/CD process in general, lots of them, and there'll be many more using containers, right, to run this tests, builds, deployment, orchestration, and all this stuff related to DevOps or DevSecOps in general. So let's try to Dockerize our app, and then let's try to include here some Docker Compose file as well. All right, so once again, since we have a set of independent services, we need to provide the distinct Docker files per each app. So let's just start, for example, with the gateway. And I'm just going to put here under the gateway directory a new Docker file. So let me just put it here under gateway. And then let's just, by following the convention, name it a Docker file. All right, so that's cool. And let's try to build our very first simple Docker file definition. So I'm going to actually follow this documentation here, kind of, and I'm going to make this multi-stage Docker file, where the first stage will be simply building our project, publishing it in the release mode, and then the second stage of the Docker file will be just running our app. So I'm going to use the official image from the Microsoft. So I have this, there is this image for the .NET SDK 6.0, and I'm just going to ls it as the build stage of our first multi-stage Docker file process. And then let's just assign there some kind of working directory, so it's a bit more organized within the container. So we'll be keeping our app, our project, our DLLs under this app directory. Then let's just copy all the stuff. And one important thing to note is that just like with the git ignore, you probably want to put there some docker ignore file. So let's place there next to our Docker file the .docker ignore file, so we can ignore some stuff. All right, so let's see. And here I can just take basics like bin object files, but we can of course make it a bit more sophisticated, including some maybe tests or other projects that we don't want to include within our final release of the project. But let's just start with the default simple bin object files to be ignored by the Docker build. And now within the first stage of our Docker build, we want to publish the project. So I'm going to just type .NET publish, and then I want to publish our feeder.gateway. So feeder.gateway. If we had there the solution, we'll probably publish the whole solution and all of its projects internally. And then let's just publish it using the release mode, and let's just publish it into some kind of the out directory. So in the next second and the last stage of our multi-stage Docker file, we just want to use this output of this first stage as the input to the second stage of this multi-stage Docker file. So here I'm going to use another base image, but instead of the SDK, we are going to use actually the .NET and the ASP.NET runtime. So I want to have a lighter image using just the runtime. Now, within the next step, once again, let's just reuse the same working directory, being the app, and then we want to copy. So I'm going to point that we want to copy from the build. So we have this build directory here, and want to copy from this directory the output. So I want to copy from this build phase whatever lives under the app/out directory, which is actually this, right? So we release this into this out directory, and I want to copy these files. And I want to copy all the files to our current app working directory. Now let's set up some variables. So here we'll set up once again the same variable as we did here, our default built-in ASP.NET Core environment variable. And I'm going to provide here the Docker value. As you can imagine, we might want to have additional app settings of Docker JSON file, for example, if we were to use some Docker infrastructure or other Docker containers within our overall system. And now let's put another URL, so another variable. So I'll just call this one, we have these URLs, and here I just want to bind my app into this internal AT port, just like for default web apps. And then we are going to start the app by providing this entry point, and the entry point will be our, the feeder.gateway and then the DLL file, and then we're just going to call .NET. So we want to execute our .NET runtime, and we want this runtime to run this FeedR gateway DLL file, which has been published in the first stage of this multi-stage file, and then it has been copied as this using this release mode, using this second stage here within this copy command in this Docker file. So let's try to actually build this image, and let's see if we can run this. So now let's jump back into our console, and let's move into our gateway. There is our Docker file, and let's just type, let me just see, we should be able to see our Docker ignore as well. Okay, it's here. So let's just type docker build, and I'm just going to provide here the tag. So let's say feeder-gateway, and then the context, which will be our current directory. So it should build. It should, of course, pull the latest SDK versions if you don't have them yet. And let's see if this is going to work. All right. As you can see, we had some warnings there. We'll get back to this in a moment. But for now, it should still work. So let's just try it out. So I'm going to do docker run, and I'm going to just auto remove it. When I click Ctrl+C, I'm going to make this run in interactive mode so I can actually close it within my terminal. It will not take over my terminal. And then let's just expose our gateway under the 5000 port with its internal 80 port, which was declared here within this variable. And let's just provide our name of the image. So there's a feeder gateway. All right, so as you can see, it's running. We have this structured logging in place, which doesn't look too nice, at least here. But of course, we can fix this later on if needed. So let's take a look. Let's see if we can reach our gateway. And there it is. We have our gateway running from the Docker, which is great. And we can kill it, and there is like no sign of other containers. But there is one issue. Now, imagine that we were to use some kind of, let's say, shared libraries components. So, for example, let's now quick into our rider. Let's just jump into our rider quickly. And let's say that within the shared, we would put there something like, just to give you an idea of what's going on. Let's say some kind of dummy type. And now let's assume that I would like to use this type, for example, within my gateway or another project, because our services are actually referencing this. We mentioned that this shared project might be used for sharing some kind of cross-cutting concerns, infrastructural concerns, just some components like middlewares, logging, authentication, database connections, and so on. So we don't have to re-implement them every time within each service, right? So let's say I would like to use this dummy somewhere here. Doesn't matter where. Let's say dummy equals new dummy, all right, from our shared. So of course it will build, it will start, but if we jump back to our gateway, let's see what happens. So if I try to do docker build once again, let's take a look. We are getting an error, right? Because this shared sys project reference, it has been skipped, but since we tried to use it, we are trying to use some of its internal components or public components in this scenario. It's, well, it just fails because this is the context of our Docker build, this current directory, and we can't really, let's say, use the, let's say, components, code, or any other files from the upper directories. This is, of course, done purpose by the Docker, security, and other important reasons. So what we can do to fix this, let me just remove this code. And what we can do instead, for example, here, we have two options. So one option, I mean, the ideal option would be to stop using this as a shared project, as a reference, but instead, as you can imagine, we could do something like feeder.shared, and we will just publish this into our, let's say, custom NuGet or public NuGet repository. So we could reference this using as a NuGet package, and the problem would be gone, right? No issues. Especially later on, if we were to, for example, extract this gateway or any other service into the distinct repository, we would most likely need to use NuGet, right? NuGet packages, custom private or public NuGet packages to resolve these issues with referencing some shared project. But let's say we want to develop the app this way, maybe until we decide to split this into distinct services, put them into separate repositories. So how can we still make it work with a Docker within this solution? So we can actually, of course, we can fix this. So let's see what we can do instead. Now, here, what I will do is something like, I'm going to call this .NET Publish, but I'll provide as a path my SRC gateway and FeedR gateway. So the whole path to this directory. All right, so now let's try to build it for our terminal. So here I'm just going to type docker build. Once again, our tag, which is the FeedR gateway. But now I'm going to provide here the path to our Docker file, which is going to be the SRC gateway and then Docker file and then the context as a dot. Now let's see. We have restored our shared projects and there is no issues. We can run this once again and this is going to work. So that's great. Now we have a way to actually build our projects, build our Docker files, custom Docker images from this root directory, and we can use this, let's say, shared project references between these services to share some cross-cutting concerns, some components used across different microservices, which is great. So now let me just copy and paste the Docker files for the remaining services, and let's move into the final phase of this episode, which is going to be our Docker Compose. Okay, so as you can see here, we have a bunch of Docker files per each service. So there's aggregator, there are our 3 Docker files for each feed, there's our gateway as it was before, and there's our notifier Docker file. So now we should be able to build them one by one. But again, since our services start growing, we probably want to put them under some, let's say, single file. So just like we did with our, for example, PM2 or TyYAML, we want to have a single file, let's say, to rule and run and build them all. So we already have within our compose 2 kind of empty templates. So one template that we'll use from Docker Compose for our infrastructure purposes. So right now it does nothing special. It just declares a network, but there is no, let's say, databases or message brokers yet. We'll get to that in a future episodes. And we have our services YAML, under which we are going to keep our Docker images, our containers for our internal microservices within the solution. So let's just start with the definition of this services. So I can do something like services, and then let's start with our gateway definition, starting with the gateway service. And important part is that I'm going to provide the build command, the parameters for the build process, which is going to be the context. And the context we want to build from the root directory. So the context needs to go one level above. And then the path to the Docker file, which is going to be our SRC gateway and then the Docker file, right? And then we can provide some additional stuff. For example, let's say the container name, I want to call this FeedR gateway. And let's say the restart, I want to restart this up until I stop it manually. And then let's just expose the ports. So I wanna expose our 5000 port, public port, being mapped to this internal 80 port for this within this container. And then I want to, let's say, join the FeedR network. So currently here we have declared that the FeedR network is going to be external. As you can see, it will try to connect to this network declared here within the infrastructure layer, within this infrastructure YAML file. But since we are not going to run this file yet, I'm just going to comment this out. And once we start adding the components, the containers, images into our infrastructure, then we can just comment this one, let's say, back to point to this external equals true network. So let's see if this is going to work for our very first gateway declared within this Docker Compose. So I can do Docker Compose, but at first let me just jump into my compose directory. So I can do Docker Compose and then -f, our services YAML, and then let's try with the build first. Let's see if it's going to build. It seems to be building. So now we can do Docker Compose, -s services YAML, and then up. And then I will just type up -d. So it runs in the background. And let's see Docker PS. There is our container. We should be able to, let's say, reach it. There is our gateway. We should be able to take a look into these logs. For example, Docker logs FeedR gateway by using the unique name of this service. So it's working. And then we can just do something like Docker Compose and then down to stop the services. And finally, we can do something like, once the services stops, we can do something like Docker compose, and then, for example, Docker system prune to prune the intermediate layers images that were used for other builds within our Docker file definitions. So let me just copy and paste the remaining services to our Docker compose YAML, and let's see if the whole solution starts using this Docker compose. All right, so there is the list of the remaining images definition, aggregator, notifier, and our free data feeds. As you can see, just copy and paste the same build params, context, just pointing to different Docker files using different container names and exposing different public ports. So now we can run our final build. So we just do Docker build, or actually Docker compose build once again. So Docker compose build, and it should build all of the services. Of course, it might take a while, especially for the first time when you need to build all your apps from the scratch. But this is actually, I mean, the containers in general are very cool, not only in terms of the deployments or testing, but for example, in terms of cooperating between different teams, because now you could just provide this compose file, let's say, to your coworkers working on front end or anything else, or manual testers, quality assurance team, and they can just run your whole system using this compose file. As you can see, it built actually quite quickly. So let's try to run our apps. So I'm going to do app -d, and let's see if this is going to start. We should see now the Docker compose, the Docker logs, or actually we can do something like Docker compose -f, and then the overall logs. There are the logs for all the apps. I can also see something like Docker compose ps for our services YAML. Yep, so it seems to be up and running, all of our apps. Let's take a look. There is gateway, there is aggregator, there is the notifier, and then there are our free data feeds. So we just talked about the Docker and compose and how we can use it for our purposes. And later on, with some additional work, we could, for example, reuse our Docker file definitions to build our images, push them to some Docker registry containers, Docker registries in general, like Azure or official Docker Hub or any other containers you can think of, especially the private ones for your, let's say, private or commercial project within your company. And then we could, for example, put their Kubernetes or other orchestration engine to deploy them somewhere into the bare metal on-premise or into the cloud, into some maybe managed environment within the cloud. So that's it from the code perspective. And now let's just quickly jump back into the summary of this episode. All right then, so hopefully after watching this episode, you have some better understanding now how we can use different tools regardless of whether you are working with .NET apps or Node applications or Java apps, that can help you with actually quickly building and running your apps using the very popular libraries and tools like, for example, Docker or containers in general that are available out there. And later on in the future, you can apply, for example, this containerization process to deploying your, let's say, services into orchestration engines like Kubernetes or OpenShift or any other orchestration engine that you can think of, or maybe plugging this into your, let's say, build or test pipeline, CI/CD in general. So that was the second episode. We have now prepared ourselves to be able to, let's say, quickly build, run, and possibly deploy our apps out there somewhere. We'll see whether this is going to be maybe in one of the future episodes, some kind of bare metal on-premise or cloud. We'll see. But that's it for this episode. And yeah, once again, thanks for watching and see you in the next one.